Hi guys, good evening. Can you hear me? Hello.
Yes, sir.
Yes.
Yeah. So thank you. So let us start session. Yeah, everyone, board members. Okay. Yeah. So let us start session. So yesterday's session, the introduction discussed. Yesterday started. Actual class started yesterday. So yesterday, just introduction to software. Java not started. Just only software introduction initially. Introduction to software. Yes, in the system software, next application software. These things discussed. One second, just a minute. Yeah. So yesterday, software introduction. Yes, about system software and application software. Discuss. So Java is application software, right? And next about OS. Yes, about BIOS. So BIOS is a first program in your system. BIOS is a first program. Okay. First BIOS starts. Once power on system, BIOS starts. That BIOS is responsible to boot your OS. So first BIOS, next OS. Next, what is OS here? See, OS on top of hardware, OS running, on top of our OS, all programs running, right? So your OS is like a platform. OS is like a platform, on top of it all are running. So what is OS means? Just it's a platform. OS is a platform where we can run all the programs. Okay. Not only platform, even interface also. Between application software layer and hardware, just its interface. Okay, fine. Next, Java is application software. So moving to application software. In application software, there's a front end, back end. In application software, there's a front end, back end. So what is Java? Java comes under back end application. So here, back end. Java here. Java is a back end. Java is a back end software. Java is a back end software. Right? See, in front end, back end, there are two things like language and package. Java is a language. Package means no coding. In language, coding. Java comes in languages. Yes, in languages. Okay. Languages. Yes, there are two types of languages. The low level languages and high level languages. Low level language. Yes, it's a system understandable language. It is in the form of binary code, 0s 1s format. System means it's a processor. It's a processor understandable language. Processors like 8085 and 8086. Now, presently we are using 8086. Okay, right? Yes. Next, it is called as machine language. Low level called as machine language. So this topic yesterday discussed. Okay. And next, high level language. High level language. Yes, it's a user understandable language. Yes, it is like English language. It's very easy to understand here. So these are high level language examples. High level language. So which is first developed high level language? C language by Dennis Ritchie in the year 1972. Right? See, every high level language program has to convert into binary code. Which one will convert here? High level language to binary code. For this, either interpreter or compiler. Yes. Now today topic is about interpreter and compilers. Yes, interpreter and compiler. Let us see about interpreter and compiler. See, interpreter and compiler. Interpreter and compiler both are to convert. Both are to convert from high level language to binary format. High level language to binary format. Both are to convert from high level language to binary format. Okay. Yes. So here interpreter, compiler, both are to convert from high level language to binary format, but way of working is different. Both are doing same process, same thing, high level to binary code, but way of working is different here. That way of working is different. Let us see. First of all, about interpreter, how interpreter is working. Let us see about interpreter. About interpreter, how that interpreter is working. About interpreter. See about the interpreter. Let us see about interpreter. How interpreter is working. Okay. Yes. Today topic is about interpreter and compilers. Okay. So yesterday, this yesterday topic, right? Yes, high level language, low level language, and high level language. So interpreter or compiler converts from high level language. This is your topic. Yesterday's topic. This is same viewers note, but this is yesterday explained. This yesterday topic, right? The generation of computers. Next about AI we have discussed. Okay, AI examples discussed. Okay, low level language, high level language. These things discussed here. Yes, now here, yes, interpreter and today topic is yes, interpreter or compiler to convert from high level language to binary code. So topic is about interpreter and compilers. So today topic is about interpreter and compiler. So first let us start with interpreter. So for interpreter, I'm taking Python. Python is the best example for the interpreter. For compiler, C program, C language. For interpreter, just I'm taking Python. For compiler, I'm taking C language. Yes, let us first interpreter, Python example. Interpreter. So for this interpreter, I'm taking Python example, Python example, Python script, Python. So Python script, some test.py, Python script. I'm taking some Python script. Yes, one second. So to write the Python script, just I'm taking simply Notepad. It's very simple program. Yes, simple program. Program to add addition, subtraction, multiplication of two numbers. Very simple program. Addition, subtraction, and multiplication of two numbers. Very simple program. So for this, I'm taking some Notepad. Suppose sample folder here is a yes, that Python script I'm taking here. So D drive sample folder here I'm writing using Notepad. Just I'm writing that Python script. Okay. See, actually Python application development is we have the PyCharm. There is a PyCharm. PyCharm development to this IDE. Using PyCharm we can develop, but it's not necessary now. It's very simple script. Very simple script. So I'm going with Notepad. Simple script. Simply I'm going with Notepad. So D drive sample. So D drive. First we should go to D drive. How is first CMD command prompt. Open command prompt. After opening, from this go to D drive. D drive. So D colon that will take to D drive. Taken CLS to clear the screen. Now we are at D drive. Now check the contents of D drive. DER, right? DER. See that all this displaying D drive contents. What is this DER? This DER stands for what? Anyone idea? What is the DER? Yes, anyone? What is DER?
Directory.
Directory. DER means directory. It's a directory. It's a DER means directory. It's a directory. It's a directory. Okay, DER means his directory. His DER means his directory simply. Okay. So DER means directory. So DER means directory. Directory, right? See, all their directories. MNRAW is a directory. MNRAW Advanced Java is directory. MNRAW Framework is directory. MNRAW Hadoop is directory. MNRAW Java directory. Okay, all the directories. Same thing. D drive contents. So you get directories. Same thing. Yes, in Windows. D drive here, see this. MNRAW Raw Advanced Java, frameworks, Hadoop, Java, all folders, right? So Raw folder, all are starting Raw, the folders. Same thing here is a directory. So directory folder both are same. Directory folder both are same. Okay, so this is Windows, Windows GUI. Windows GUI is a graphical user interface. Windows is a GUI, graphical user interface. Graphical user interface. So here it's a, this is called as folder. Here is a folder. Same thing, character interface. This is CUI, character user interface. So you can call it directory. See operating systems like GUI and CUI. GUI. So Windows is a GUI OS. Windows is a, yes, Windows OS. Yes, Windows OS is a GUI, right? GUI. So GUI means, so GUI, yes, graphical user interface. Interface, right? Yes, next. So this is here, it's a, this command prompt, command line. So this is character user interface. CUI. This is CUI. CUI, or we can say CLI also. They are basics simply here. Basics of software. CUI stands for, yes, character. Yes, character user interface. Character user interface. CLI means command line. Command line interface. Command line interface. Okay, so this is CUI. So this is CUI or CLI. It's a command line interface. Next, this is GA. There's a difference. So Windows is a GA OS. Windows is a GA. Command prompt is a CUI, character user interface. It's clear. Okay. See Windows D drive contents. These are the contents of D drive. Contents of D drive, right? See that here. D drive, D drive contents, these things, right? Now here MN drive say DER means directory. MN drive is a directory. Directory, all directories. Same names, here is a folders. That means folder directory both are same. Folder directory both are, only terminal difference here. Folder, see folder on directory. Folder on directory. Folder directory. Both are same. Only, yes, only terminal difference. Terminal difference. In GA calling as folder. GA is a folder. It's a folder. Same thing, character interface calling as directory. That's it here. Only terminal difference, both are same. That's okay, fine. Now come to actual topic. Let us come to actual topic. So what is our actual topic? About interpreter. Topic is about interpreter. Topic is about interpreter. For interpreter, I'm taking Python example. Python is a interpreter based. So for Python, I'm taking here. So Python, yes. Yes, Python is a interpreter based language. Let us see about Python. Some Python script. Yes, at the command prompt. Here I'm writing some Python script. See, 1 second, exit. So Python scripting. Yes, in D drive sample folder. Here I'm developing one Python script. So for this using Notepad, D drive sample folder. In this, just developing some Python script. So for this, I'm taking Notepad. So Notepad means command line. We should go to command CMD. Search for CMD. That opens command prompt. After opening command prompt, now we should go to D drive. D colon will take to D drive. Now we are D drive, right? Not D are that contents. See that. D drive contents. We are all the contents. Now we should go to sample, right? In D drive sample location, sample directory. Now we should go to sample directory. How can you go to sample directory now? Anyone? Anyone from the class?
CD
Yes,
and the path.
yeah, good. CD. That name, right? CD sample. Okay. Yeah, already working is having this knowledge. Think a CD sample. CD means what? CD means,
Change directory.
yeah, change of directory. CD stands for change of directory. CD, MD, MD is making directory like that. CD, sample, change, right? Now we are at sample location, DER, sample, CLS to clear the screen, not DER to check the contents. Sample directory, see, directory of sample, 0 files, no files. See this here, folder is empty. This folder is empty. This folder is empty, right? Now here, let us start developing here. Yes, notepad, test.py, simple script. Yes, cannot find this file. Do you want to create new file? Yes, open it. Now here, let us start writing program. Yes, here I am writing very simple script. Very simple script. Yes, a equal to 10, variable a 10, b value 20, c equal to a plus b, just its addition. Print addition. That addition value. See, displaying c value. Next, c equal to a minus b. Print subtraction. Subtraction equal to displaying c value. Next, c equal to a into b. Print, yes, multiplication. Multiplication is equal to displaying c value, right? Yes, very simple script. Yes, very simple script here. So a equal 10, b equal 20. So first addition, next subtraction, next multiplication. Yes, save it, control yes, save it, save and close. Save and close. Now go to command prompt. DER, check it. See that file created, test.py. Sample folder here, test.py, that Python script, right? It's there. See that Python script file, right? Now this one we should run it. Python interpreter. Yes, test.py. Yes, interpreter is responsible to run the Python script. Yes, Python test.py. That interpreter running that script, right? So addition, subtraction, multiplication. See, our topic is not about Python. I am not talking about Python. I am not explaining about Python. I am explaining about interpreter. So our topic is about interpreter. Today topic is about interpreter and compiler. In that, I am explaining about interpreter. For interpreter, best example, Python is the best example for the interpreter-based language. Python is the best example for interpreter-based language. So in order to explain interpreter, I am explaining Python program, simple program. This I have taken very simple program. Right? See that output. That Python test.py. Addition equal 30, subtraction minus 10, multiplication equal 200. Suppose any mistakes, then what happens here? Suppose here something wrong. Suppose here bracket missing. Suppose here double quotation missing. Suppose here comma missing. What happens? There are 3 errors. Totally 3 mistakes in this program. Here first error, next here second error, third error. Now run it. Yes, run it here. What happens here? See, interpreter. See, actually here any program, first of all, checking for errors. If no errors, then executing, right? Suppose if it is C program, first you have to compile it. Suppose if no errors, then running, right? We have C programming is first compilation. If no errors, then running program. When come to this interpreter based. Yes, no errors checking, directly executing. No errors checking, directly executing. Now here I am executing this program. The script executing directly. Python interpreter, so test.py. So Python, this is Python interpreter to run our script here. So it's a Python interpreter to run Python script. Enter key. See that error, right? Yes. Line number 8 is error. But actually there are 3 errors. There are 3 errors, but showing only 1 error. Okay, there are 3 errors, but showing only 1 error. So what is happening here? If any error comes, simply interpreter stops. Let me explain clearly. If any error, interpreter stops. It won't check for next statements. Let me explain clearly. Yes. So how that interpreter is working, let me explain clearly. Interpreter. The script statements. Suppose first statement. First statement. Okay. So next statement. So next statement. Like this, some statements like this. Some statements. Yeah. Some statements. Some statements. Some statement. There are some state. Yes. Yes, that script statement. So A equal 10, B equal 20, C equal to A plus B. Print C value. C equal to A minus B. Print C value. Next, C equal to A into B. Print C. But like there are some statements in this script, right? Yes, how interpreter is working here? How here interpreter is working? See, interpreter checking first statement. Suppose first statement is correct. Then checks the next statement. Next statement also correct. Then checking for next statement. Suppose something wrong here, stops. That's it. It won't check for remaining all the states. Stopping here only. If any error comes, it stops. So interpreter checking line by line. Checking first line. If it is correct, then checking next line. If it is correct, checking next line. Something wrong, simply stops. Something wrong, simply stops. Okay. Same thing here. Yes, see this. In this script here, Python script. Python is a interpreter based language. Python is a interpreter based language. Python interpreter. How it's working here? Checking the statement, checking the statement, checking the statement here. Yes, here is the statement. It's a error. Okay. So here, this statement is mistake. Is there next? Here are some mistake. Here mistake. Total there are 3 mistakes are there, but it will not show all the errors. Any error simply stops here. Okay, so here something wrong. Here mistake, right? Simply stopping here only. Okay, save it. Yes, see this. Now run it. See that. That 8th line error. Let us correct that mistake here. 8th line. Let us correct the mistake. 8th line. So this is what is missing here? Bracket missing. Control is saved. Yes, that error fixed. That error fixed. After fixing that error, now let us again run it here. Run it again. Again run it here. See this. Not 12th line error. 12th line error, right? So 12th line error. Now it's giving 12th line error. Okay. Now let us fix that error. See, I'm using up arrow key to get the previous comments. Command prompt will maintain the history. Up arrow key. Up arrow key history. Previous comments. Down arrow key. Up arrow key. Down arrow key. I'm using up arrow key. Down arrow key. Yes. Instead of typing every time, you can use up arrow key. I want this previous command, notepad, yes. Up arrow key I'm using, up, yes. Here, right? Notepad test. So need not type every time here. That will maintain the history. Command prompt will maintain the history. Okay. When that, now see this. Now next error. So next mistake, this next mistake, right? Save it. Control yes, save it. So next, run it here. Run it. Yes. Now 16th line. So it's showing only 1 error. Actually, there are 3 errors, but showing only 1 error. So any error comes, simply stops. Okay. Now this mistake. So you say comma, right? Comma. This mistake. Save it. Save and close. Go to command prompt. Now run it here. Yes, successfully completed. So this is working. So interpreter. How interpreter is working here? Interpreter checks the first statement. If it is correct, checking next statement. If it is correct, checking next step. Something wrong, simply stops. It won't check for remaining statements. So interpreter checks the program line by line. Interpreter checking program line by line. Line by line. If any error comes, simply stops. If any error comes, simply stops. Simply stops. Okay, simply stops. Suppose no errors. Top to bottom, all the statements checking completed. All the statements checking completed. Suppose no errors. So checking line by line. Yes, suppose all lines checking completed. Suppose no error. Then what happens here? Then now execution starts. First statement. So this first, if yes, first statement already checked, right? So this first statement now it converts into binary code. That interpreter will convert this first statement into binary code. Zeros ones form. Interpreter converting that code into binary format and given to processor. Right? So processor taking that code, generating output. So next you take next statement. So line by line. So this is the conversion also line by line, not at a time here, line by line conversion and given to processor, just giving to processor. So processor generates outputs, generating output. So next statement. Okay, so next statement. So next statement also convert into binary formats. So one statements are correct. Now line by line converting into binary formats and given to processor and generating outputs. Generating output, right? Outputs. Like this start. So line by line. So interpreter checks the line by line and also execution line by line. Line by line conversion, then execution. First line conversion, then execution. Second line conversion, then execution. Third line conversion, then execution. Next line, next. So line by line execution. So this is interpreter. Okay. Any error is there, simply stops. Any error, it stops simply. Interpreter, this is right. Now, compiler. So let us see compiler. How compiler is working. About compiler. Yes, about compiler. How that compiler is working. About the compiler. Let us say about compiler. For compiler, I'm taking C program example. C or C++, both are same. Yes, compiler. C++ compiler using for both C and C++. Yes, C++ compiler using for both C and C++. So compiler. So for compiler, I'm taking some C program. Just I'm taking C program. So about test.c. Okay, C program. So C++ is CPP extension. For C++, CPP extension .c. Now I'm taking C program. Okay. Yes. How compiler working? Compiler working. About compiler. About the compiler. How that compiler working here? Suppose compiler, some statements. How it's working? So compiler checking first line. If it is correct, then checking next line. If it is correct, next line. Suppose something wrong. Yes, compiler shows error at some line. Error at some line. Afterwards, checking next statement. Even error comes, it goes to next line also. Even error is there, it go to next line. So next line. So next line. Suppose something wrong here. Error at some line. So next line. Next line. So next line. So next line. Something wrong. Error at some line. So compiler checks the whole code from top to bottom and shows all the errors. Interpreter, any error comes, stops. Interpreter, any error, simply stops. But compiler is not like that here. Compiler, it checks whole code from top to bottom and shows all the errors. Compiler shows all the errors. Let me show the take some C program example. C program. Yes, Turbo C. Yes, it's IDE. C program. Yes, C program. C test.cpp. C++. In C, here we can write C program also. In C++ compile, we can write C program also. See void main, int ABC, yes, enter first number, enter second number, enter third number, yes, sorry. C equal to A plus B, addition. Okay. So it's addition, next subtraction, and multiplication. Right? Same program. Like Python example, C programmer, same program. Same program. Now compile it. See compile option. Here this is a compile option, right? Compile. Yes, success. Success. Warning 0, error 0. No errors. Everything is press any key. Right? Now run it. Now running program. Yes, running program. Enter first number 10, second number 20. See that? Addition 30, subtraction minus 10, multiplication 200. That's it. So here no error, successfully executed. No error, successfully completed. Suppose any errors, what happens? Suppose here semicolon missing, for example. Here the bracket missing. Okay. Suppose here comma missing. Okay. Yes. Suppose here this bracket missing. Okay. Suppose here semicolon missing. Okay. Suppose here, so this double quotation missing. What happens? Let us see. No, save it. Once program modified, that should be saved. Save. Saved, right? After saving, now I'm compiling. See, it's compile option. Compile. See this errors. Totally 8 errors, right? Errors, eight errors. Press any key. Press any key. Okay, enter key. See this. Now look at the part of line numbers, right? Line number 9 error. Line number 9 declaration syntax error. Next 11th line statement missing, semicolon missing. 16th line illegal use of pointer. 21st line, line number 21, 23, 29, 33, 35, right? See top to bottom. So compiler checks the whole code from top to bottom. Okay. Yes, look at that error. 9th line error. That message at the bottom. Look at the bottom. Here, look at the bottom. I'm showing with mouse pointer. Yes, 9th line error. Next 11th line error. See 9, 11. Next 16, 21. Yes, 23, 29, 33, 35. Right? So compiler checks the whole program from top to bottom. Compiler checks complete code from top to bottom, shows all the errors. Now let us correct all these mistakes here. Let us correct that mistakes. Suppose here bracket missing. Here comma missing. Okay. Yes. Here double quotation missing. Yes, some errors fixed. Now let us recompile. So save it. Save it here. Say overwrite yes. Now compile. Still some more errors. Still 4 errors, right? Errors 4, still 4. Right? Now here this is semicolon missing here. So next missing. Yes, here semicolon missing here. Okay, now save it. Save it. Say yes, overwrite. Now compilation. Still some more errors. One more error is there.
Scanf bracket.
One more. That bracket scanf bracket missing, right? Scanf. That bracket missing. Here bracket missing. Now save it. Yes, overwriting. Now compile it. Yes, successfully completed. Press any key. Okay, right? So after compilation of this, if no errors, what happens? Yes, in case of compile, if no errors, how it executes? Let us see. Yes, in case of interpreter, suppose no errors. First line converting to binary code, then executing. Second line converting to binary code, then executing. Third line converting to binary code, then executing. Line by line, right? Line by line conversion, then execution. But compile is not like that. In case of compile, what happens here? Suppose no errors, everything is fine. Suppose no errors, everything is fine. Then how it's working here? No errors. So this is fine. Yes. Here this also fine. Okay. Suppose this also fine. If everything is fine. If no errors, Now, compiler, it opens one more file. It opens one more file. After opening one more file here, so this complete code converts in binary format. This code means your source program, the source. This is called a source. The source code. Okay, that high level language is a source code. That source code simply converts in binary format. All the lines simply converts in binary format, right to another file. So binary code like this. Binary format. So binary format like this. Converts into binary format, right to another file. Right into another file. What is this file name here? Anyone? The binary code file. What is the name of the binary code file? What is name of the binary code file?
Executable file.
Yeah, good. Executable file test.exe. That will generate one test.exe file. Exe means executable file. Okay, so compiler checks the whole code from top to bottom. Compiler checks the whole code from top to bottom. If any errors, it shows all the errors. Suppose if no errors, yeah, this whole code, that source code simply converts into binary format. Source code converts into binary format and write to another file. Write to another file. That file is exe file. Exe file generates. After generating exe file, now this exe file given to processor. So at a time, so this, see, in case of interpreter, what happens? Line by line conversion. First line converting and given to processor. So Python interpreter converting line and given to processor. Converting next line given to processor. Converting next line given to processor. But compile is not like that. Compile is not like that here. So compiler, this whole code, that your source code, with this code, that complete C program code, that code simply converts into binary format. That whole code converts into binary format and write to another file. It will write to another file. That file is exe file. Generating exe file. Now this exe file. So this exe file given to processor. So given to processor. Given to processor. Processor, right? So processor executes and generates. Yes, already. So that exe file given to processor, that processor executes and generating output. Okay, let me show that exe file. Test.exe. This program exe file. See test.cpp, right? Test.cpp. For this exe file, backend, C drive, TC means turbo C. Here is installed. TC here installed in this bin folder. Inside of bin folder, all the programs. See, this is your test program. The test.cpp file here. Test.cpp. Yes, let us open, double click open. See that your C program, right? Same that program. Int A, int B, int C. Enter first number, enter second number. Yes. Next, addition, subtraction, multiplication, right? Yours, that's the source code, right? So backend program, right? See, for this CPP, let me delete all the related files here. That old files I'm deleting here. See, this is your CPP file, right? Or C program. Extension CPP, no issue. So CPP. Now what I'm doing here, I'm compiled. Success, no errors. No errors. So when I try to run it here, before going to run this program, first of all, creates one exe file. Okay, 1 second. See, now look at the bottom here, at the bottom. Yes. See, in OS, run it. That exe file created now. 27.3.20 means 8 o'clock. Application means exe file. See, check it, right click, properties. See that .exe extension, right? Test.exe file created. That exe file contains binary format. System understandable language. It's a binary code file. That exe file is a binary code file. It's a system understandable language. That exe file created. Just now exe file created. Okay, once I refresh. Let me refresh. Refresh. See that. Test. Your test program test.cpp and test.exe file. Here test.exe file created. Just now created 27.3.20. Just now created exe file. Okay. series. Enter first number 10, enter second number 20. Output, right? That's it here. Okay. Yes. Now I'm running again same program. Run it. Yes. Again the timestamp change, right? Now again that exe regenerated exe file. Regenerated 10, 20, right? That's it here. Again try to run it here. Yes. Now again regenerating exe file. I think time is same here. So 10, 20, right? Okay. Right. See compile. Yes. Run it. Yes, still time not changed here, that minute. Okay. Right. 10, 20. Right. That's it here. Okay. The exe file. So the test.exe file create, right? So when you try to run it here, that creates exe file. Exe file created. Right, that's it here. So this is exe file created and executed, right? Exe file created and executed. So this is difference between interpreter and compiler. Now tell me guys, what's the difference observed between interpreter and compiler? Tell me. So this is interpreter expand here, compile expand. In these two pages, what is main difference observed here? Interpreter compiler difference. Tell me guys. Yes, I'll explain clearly points phase. Note what you observed. What do you observed here? One point is clear in this. One point is clear. Which is observed here? No one? Simple question. So something very clear.
Interpreter execute step by step, and
That's,
compiler execute means complete program, complete code.
that's okay. But it's clear it's a difference in this space. That clear difference is there. What is that clear difference in this space? Here, only one box is there, here two boxes, right? Interpreter base one.
Interpreter cannot create any executable file.
Yeah, exactly. That exe file is a difference. Exe file is a difference here. Exe file is a main difference. Compiler always generates exe file. Interpreter never generating exe file. Yeah, let me explain the differences. Yes, points wise. Yes, very clearly we'll discuss. Yes, interpreter versus compiler. That comparison.
Sir, can we check the exe file to check the binary code? Can we do that or
No,
not possible?
not possible.
It's at
Okay.
background, right?
Once exe file created, that never changing.
Okay.
Okay. When source code you can modify. If you want to modify the program, again we should go to source code. Source code program has to modify and he has to recompile or regenerating exe file. That's it here.
It means we cannot see binary
Yeah, we
things
can't
in
see.
exe.
We
Yes.
can't see the binary code file.
It's at background only.
Yes, working in the backend. That's it. Okay.
Hello.
That binary code you can't see, even you cannot modify. Okay. Yes. Yeah. That is yes. Here, if it is exe format here, no one can change it. No chance of corrupting project. Project is exe format. If project is exe format, there is no chance of hacking code. Yes, project is exe format, no chance of data hacking or code hacking. Suppose take Java dot class format. That is also no one can hack that code. Not source format, bytecode format. Java dot class file also cannot be hacked. Take Python. Python is always source only. I mean, there is a chance of hacking code with Python. Python chance of code hacking. C programming, C++, Java, .NET, these things, there is no chance of code hacking. Okay, fine. Now let us see here. Step by step. Let me explain points wise. Points wise. Yes, interpreter and compiler. So interpreter. Yes, interpreter and compiler. Yes, we'll discuss Java also. I'll explain Java also now. Yes, interpreter. First one. Yes, interpreter. It checks the code. Yes, interpreter. It checks the code. It checks the code. Checks the code line by line. It checks the code line by line. Compiler. Yes, it checks whole code from top to bottom. It checks complete code from top to bottom. It checks whole code from top to bottom, from top to bottom, from top to bottom. It checks whole code from top to bottom. So interpreter, it checks the code line by line. Yes, compare, it checks whole code from top to bottom. Next, interpreter. Yes, it executes code. It executes, means running code. It executes code line by line. So first line converting to binary format, then generating output. Next line converting into binary format, then generating output. Next line converting. So line by line. Execution also line by line. Yes, if it is compare, whole code converts into binary format and executing at a time. Yes, it executes code at a time. Executes code at a time because of the exe file at a time, right? Next, interpreter. Yes, if any error comes, if any error, then interpreter stops. It stops. It stops. Yes, if any error, it stops here. So hence it shows only one error. Hence it shows only one error. Only one error. It shows only one error. Okay. Yes, if any error, it stops. If any error, it stops. Hence it shows only one error. Yes, compiler. Yes, it shows all the errors from top to bottom. Even error comes, it goes next. It shows all errors from top to bottom, from top to bottom. It shows all errors from top to bottom, right? Yes, next difference, most important difference, exe file. Yes, interpreter. Yes, it does not generate exe file. Interpreter, it does not generate exe file. Compiler, it generates exe file. Compiler, it generates exe file. Exe file, right? Yes, next, one more difference here. See, in interpreter case, what happens here? Yes, the source code executing directly. Yes, see, notepad. See, this is called a source code. So our program is source code, maybe Java program or C program, Python, whatever it is. What are the program we are writing? Our code is a source code. No, this is source. This is source, right? Yes, in case of interpreter. So Python interpreter. Yes, executing source code directly. No exe file. Test.py file. Test.py. The script executing directly. It executes source code directly. Interpreter. It executes source code directly. It executes source code directly. But in case of compiler, what happens here? First exe file generating. That exe file executes. That exe file generates. This exe file executes. Okay, right? That exe file executes here. That exe file executes. Okay. Yes, it executes exe file. It executes exe file. It executes exe file. Okay. So these two are important differences here. Okay. So these two are important differences. Okay. So here, interpreter does not generate exe file. It executes source code directly. Okay. Compiler case generates exe file and executes exe file. Next difference. See, interpreter based language called as scripting language. These are called as scripting language. Scripting languages. So these are called as scripting languages. So interpreter based. So these are called as scripting language. Compiler based. So these are called as what? Tell me guys. Now you can guess it. So these are called as
high level language.
Anyone? Come on, guys. Interpreter-based languages are scripting languages. Compiler-based called as what?
High level languages.
No, all are interpreter, compiler, all are high-level languages only. Whatever it is, maybe interpreter, compiler, all are high-level languages. Come on. Anchal. She's saying, trying to say something. Compiler basically called as programming language. Scripting language, programming language. Scripting language, programming language. Interpreter-based language is scripting language. So these are called as programming language. Programming language. So programming language. So they are called as programming language. C is a programming language. Python is a scripting language. Can you tell me scripting language examples? Examples of scripting language. Now you can tell it, I think.
Python.
Yeah, Python is a scripting language. Okay, good. And next, any other scripting language?
JavaScript.
Yeah, JavaScript. JavaScript, okay. And next, JavaScript also scripting language. Next, any other scripting languages? HTML is a scripting language, right? Hypertext markup language, scripting language. Next, any other scripting languages? Any other scripting languages? No idea? Yes, Perl scripting, very old one, Perl scripting. It's a scripting language. Next, PHP, also scripting language. Linux, this is shell scripting. Shell scripting, that is our scripting. These are scripting languages. In Python, for Python, Python is an interpreter. Python is interpreter for the Python. See, JavaScript and HTML. So what's the interpreter for the HTML? Tell me. So HTML executes in which environment?
Browser.
Browser, yes, good. Browser. So JavaScript and yes, HTML. So these are browser understandable languages. JavaScript and HTML. These are browser understandable languages. So browser is an interpreter. So JavaScript and HTML, for these two things, browser is an interpreter. This executes in the browser environment. So it's a browser understandable language. Browser is an interpreter. JavaScript is not a Java. Don't think JavaScript is Java. JavaScript is different. Java is different here. JavaScript is not a Java. One second. Let me show that. In previous session, we have discussed that point. See, web application. Here, Java here working. JavaScript here, right? JavaScript working here. JavaScript working in the browser, means client side. Java working at the server side. Okay. So JavaScript is a client side programming language. Sorry. JavaScript is a client side scripting language. Java is server side programming language. JavaScript is a browser understandable language. Java is a JVM understandable language. That is different, this is different. Okay. JavaScript different, Java different. JavaScript working at the client side. Java working at the back end or server side. So Java client side, sorry, JavaScript is a client side, Java server side. JavaScript is for the client side validations. Java for the server side validations. Next, JavaScript is a browser understandable language. Java is a JVM understandable language. JVM understandable. So both are not same. So JavaScript working at the client side, Java working at the server side. Okay, so client is a front end, server side back end. So JavaScript is front end, Java is a back end. That's it here. Okay, yes. So both are not same, different things. Okay, fine. Next, Perl. It's having its own interpreter. PHP own interpreter. See, Perl and PHP, they are very old languages. Okay, still using server side using this is scripting. Server side scripting purpose. Shell. Linux shells, most important. Linux shell scripting. Linux environment shell scripting. Suppose applications deploying in the server. When applications are deploying in the production environment servers here, Linux shell scripting will be useful here. So these are interpreter-based languages. Yes, next, compiler programming language examples. Tell me, guys. Compiler-based examples.
Java.
Not discussed.
C, C++,
Compiler-based example.
Java.
Just not discuss. C and C++. And next what?
Java.
.NET C#. Next what? Java. No. Just wait. About Java, wait. Okay. Yes, next. Here, one point clear here. Interpreter-based language don't have exe file. Yes, interpreter-based languages don't have exe files. Don't have exe file. Don't have exe file. Yes, compiler here, everything is exe file. Everything generating as exe file. Yes,
Sir,
always.
basic is also a programming language, no?
Which one?
Basic.
Yeah, basic also programming language. Basic, COBOL, basic. Okay, COBOL, basic, Fortran, they're programming languages. Compiler based. Okay, old languages. COBOL, basic, Fortran, those things. Okay, fine. No. Okay, fine. Everything is fine. Interpreter, compiler, defense is clear. Scripting language, okay. Program language, okay. Everything is fine. Now, where is Java now? So we are discussing about everything fine. But what about Java? Yes, we should discuss about Java also, right? What is Java? Okay, let us start Java here. Java. So what is Java? Yes, is it compiler based or interpreter based? Anyone can you answer this?
Compiler based.
Java is a compiler based. Okay, Santoshi saying that it's a compiler based. Next. Next, anyone, can you guess it? Compiler or interpreter?
Compiler.
Joshi saying that compiler. Next. Geeta saying that compiler. Next. Next, anyone?
Compiler based.
Compiler based. Okay,
Sir,
next.
Java is a platform independent.
No, I'm asking you, is it compiler or interpreter? These are the features, independent of platform, portable, these are features of Java. Okay, I'm asking, is it compiler based or interpreter based? That is question. Bhavan is saying something.
Sir, both.
Bhavan is both. Who is saying both?
Achal.
Anchal saying that both. Okay. Next. Okay.
Yes, sir. Java is both.
Both. Bhavan is saying that Bhavana. Okay. Bhavana part is saying that both. Okay, fine. Yes. I will explain. You decide it. I'll explain about Java. You decide it finally. Okay. See. Except Java. In other languages like C, C++, Python, maybe .NET, any except Java. In other language, what happens here? So first of all, source code converts into binary format. Source code converts into binary code. That binary code given to processor. So processor taking that code, generating output, right? This is what is happening in other languages. C language, C compiler converting source code to binary code. Python interpreter converting source code to binary code. So HTML, browser converting source code to binary code. Okay. A JavaScript, same, browser converting from source code to binary code. So either compiler or interpreter converting from source code to binary code, then given to processor, finally generating outputs. Now let us see Java. In Java, what happens? So first of all, Java source code, first of all, converts into bytecode format. This is a bytecode. That bytecode to binary code. That binary code given to processor. So processor. Now processor executes on generating output, right? Yes. bytecode. Yes, yes, in Java there are two stages. First stage, source code to bytecode, and next stage, bytecode to binary code. There are two stages here. Java program working in two stages. Others are only one stage, only one step. But Java, two steps or two stages. Okay. So bytecode. Yeah, there is the intermediate code, right? In Java, some intermediate codes. So why this bytecode introduced here? Yes, in Java, bytecode was introduced. Yes, introduced to make Java as independent platform, to make Java as an independent platform, Java as independent platform, independent platform, right? Independent platform. Okay, independent platform, right? So in Java, bytecode was introduced. Bytecode was introduced to make this Java as independent platform. Yes, about independent platform in next session. I think maybe tomorrow session. Okay. Yes. How would Java made us independent platform? The topic tomorrow getting. Okay, fine. So you can source code conversion to bytecode to binary code. So you can bytecode, that intermediate code, bytecode introduced to make the Java as independent platform. Now in this source code to bytecode, who will convert the source code to bytecode? For this Java compiler, Java compiler converting from source code to bytecode. Okay, right? Next, second step, bytecode to binary code. Who will convert it here? So bytecode to binary code. This is by the Java interpreter. Yes, I will show that practically now. Java interpreter. So first step is, first stage, two stages. First one, compiler, and next one, interpreter. Yes, let me show some example. Let us see Java example. Let us see Java example. D drive, same sample folder. Yes, I'm taking Java example. See, for Java, actually Eclipse is there, but I'm not showing Eclipse here. Eclipse next session I will discuss. Leave it now. I'm using simply Notepad. So this is actually Eclipse. So Eclipse program. Okay, one second. Not Eclipse. I'm using simply Notepad. So D drive sample folder. Here I'm developing simple Java program. Yes. See. Now open a command prompt. CMD. Go to command prompt. Yes. From this now we should go to D drive. How can you go to D drive? D colon. That will take to D drive. Taken. Right. CLS. Clear the screen. From D drive. DER output. DER output. Okay. Now sample. The sample directory. Okay. CD change of directory. CD sample changed. CLS clear screen DER. Now let us write simple Java program. Notepad test.java. Yes, open. Do you want to create new file? Yes. Now simple Java program. Public class test. Okay, public static void main string scaps string array of args, square bracket means array, main starting, ending, is system dot out dot println semicolon, yes, hello world. Save it. Control S, notepad save. Go to command prompt, dir check it. Test.java, right? Now this program we should compile it first of all. Java C means Java compiler. C means compiler. Java C means compiler. Test.java. Test.java compiling. Yes, compiled. Compiled. Generated one test dot class file generated. The program compiled and generated dot class file. Okay. Suppose any errors, some mistakes, suppose here bracket missing, semicolon missing, open brace missing. Save it. Save it. Now, let us recompile. Test.java, just now created. Java C, test.java, comparison, set errors. Expected bracket, expect semicolon, expect, so 3 errors. So all the errors from top to bottom. So compiler shows all the errors from top to bottom, right? Same thing happens here. Compiler, it shows all the errors from top to, like C programming here also, all errors from the top to bottom. This is compiler. Okay. Yes, now let us correct all that mistakes here. Semicolon and closing brackets. Save it. Save. And let us recompile. CLS Java C test.java recompilation. Recompiled. Yes, no error. Generated one dot class file. Just now. 2028 means 8 o'clock 28 minutes. Just now generated. Now what's happened here? Test.java. Yes, this is given to test.java, which is source code. So this is source. So this is source code, right? Source code. Source, this is source code. Test.java is a source code. This is source code. 1 second. One second, this. 1 second, guys. Yeah. Source code. Yes, source code given to Java compiler, Java C, Java compiler, checking for all the errors. If no errors, generating test dot class. Result is dot class, right? That dot class is a byte code file. It's a byte code. Okay. So test.java, source code given to Java compiler. The Java compiler generated dot class file. Byte code, right? So we got the byte code file. After that, now we should run it. Java test. Java test. Java test. Running test file here. Java test. Yes, executed hello world, right? See here, Java C means is a Java compiler. Here, this Java means this interpreter. So Java C means it's a Java compiler. Here, Java means this is interpreter. Program error checked by the compiler. No errors, generated dot class file. Now program execution by the interpreter. Interpreter, so interpreter taking dot class file, means byte code file, converting into binary format and executing line by line. Executing line by line. Okay. Now here, so tested dot class files. Now this dot class file taken with Java interpreter. The Java interpreter, it's an interpreter, Java interpreter. Okay, interpreter generating, yes, binary code. It converts the code line by line. Line by line and given to processor. That will be given to processor. So processor taking that code and generating output simply. That's it. So what is happening here? So first part, source code to byte code by Java compiler. Yes, byte code to binary code by the Java interpreter. So what happens here? Yes, here Java program errors. Errors checking by the compiler. Errors checking by the compiler. If no errors, then program execution. Program execute dot class for program execution. Execution. Yes, execution by the program execution. Execution by the interpreter. By the interpreter, right? By the interpreter. So there are two things involving here, compiler as well as interpreter. Java compiler and Java interpreter, both are involved here. Okay. So here, so both are involving. Okay. Compiler, interpreter, both are involving here. Compiler and interpreter, both are involving. So compiler, interpreter. Yes, in case of Java, both are involving compiler as well as interpreter. Both are involving. Both are involving. Okay. Both are involving, right? Yes. Now Java depends on what? Is it compiler based or interpreter based? Now tell me, guys.
Both.
Both.
Compiler and interpreter.
It's clear, right? Both.
Yes.
Java depends on both here. Yes, Java. Java depends on both. Java depends. Java depends. Depends on both. Depends on both. Yes, compiler as well as interpreter. Compiler as well as interpreter. Compiler as well as interpreter, right? Both here, depending on both. Java depends on both compiler as well as interpreter. I think it's clear. Now, some question for you guys. Some question. Can we create exe file in Java? Yes. Anyone, can you answer this one?
Yes.
Can we create exe file in
No.
Java? Santoshi, yes. Next
Yeah.
others. Tell me, can we create exe file in Java? Okay, Santoshi, fine. Now here, so these are Java steps, right?
Yeah.
So first Notepad, using Notepad, Java program developer, Notepad test.java file. Okay, fine. Next, what is next step here? Next step, compiled. Java C compiled. Result is what? Dot class file. Dot class file. Then execution, Java test executed. In this process, have you seen any .exe file here? Santoshi.
No, but what you have written on the screen, I saw that one source code to that converting to the bytecode. In that, I saw the text is something written there. So, could you please show the screen, please? Yeah, but yeah. That, no,
Bytecode
not that
line.
much. No, little down. Yeah, this one. Text.class.
Dot class file. Dot class file taken by the interpreter converting into binary code, right?
Yeah.
It converts first line converting into binary code, then given to processor. Next line converting to binary code, given to processor. Next line by line conversion and execution. No exe file. Okay, right?
So
Yes.
line by line conversion is coming under exe file, no, sir? Just now you told
No,
me.
no.
Interpreter
Yes, line by line
converts.
conversion. It is interpreter line by line converts and executes immediately. It won't generate exe file. No result file. First line converting and giving to processor immediately. Next line converting, giving to processor. Next line converting, giving to processor. But in case of compiler, what happens? That whole code converts into binary for writing to one file. Writing
Okay.
to one more file. But here, second file will not generate. Line by line. Java also same. Okay. So only dot class file. Java only dot class file. It won't generate exe file. So Java don't have exe file concept. Yes. Can we create exe file in Java? Answer is no.
No.
Answer is no.
Yeah.
See,
Okay.
yes, see in Java, so exe file, exe file concept eliminated. Yes, eliminated from Java. Exe file concept eliminated from Java. Yes, to make it as independent platform, to make it as independent of platform. That's main reason here. So why exe concept removed from the Java to make it as independent platform? So wherever exe file concept is, that is platform dependent. C programming is exe, that is platform dependent. .NET exe base, that is platform dependent. C++ or CXE, those are the platform dependent languages. But Java is independent of platform. Yes. So reason here, exe file concept removed to make it as independent platform. Yet the topic we'll discuss next. In tomorrow's session, I'll explain about exe file dot class file. Okay, exe file dot class for differences. Okay. Yes, next, how Java made us independent platform. Tomorrow's session we'll discuss. Okay. See, Java don't have exe file concept. Java don't have Java don't have exe file concept. Java don't have exe file concept. Since Java, everything is a dot. Java, yes, everything is a dot class file. Java, everything is dot class file. So you get dot class is not exe file. Dot class file is not an exe file. Dot class is not an exe file. Exe file different, dot class file is different here. See here, exe file. Exe file is a binary code file. Exe file is a binary code file. It's a binary code file. But dot class file is a bytecode file. What is exactly bytecode? We'll discuss. In Java, I will explain what is exactly bytecode. We'll discuss in Java. Next, exe file is a binary code, but dot class a bytecode file. Bytecode file, right? Next, exe file, yes, is a system understandable language. Exe binary code is system understandable language. System understandable language. System understandable language, right? The dot class file, whereas dot class file is a JVM understandable language. Dot class file is JVM understandable. Yes, about JVM next session I'll explain. We'll discuss one session separately. JVM topic is interesting session. JVM. Yes, we have separate session on JVM. Right. Next, exe file is a platform dependent. So exe file is a platform dependent. Why exe file is platform dependent? Tomorrow topic. Tomorrow we'll discuss about dot class files, exe files. Dependent. Yes, dependent. Okay. Exe file is a platform dependent. Yes, but whereas dot class file. Yes, whereas dot class file is a independent platform. Independent of platform. Right? Yes. Tomorrow we are going to discuss about how Java made us independent platform. The topic tomorrow we'll discuss. Right? So this is Java introduction. Okay. So Java depends on both interpreter as well as compiler. That's it here. Yes. Tomorrow topic is here. How Java made us independent platform. Okay. Yes. Next, how it is portable. Those things we'll discuss. And next Saturday, going for Java installations. Saturday. Tomorrow, very interesting topic. Saturday, Java installation, Eclipse installation, JDK and all that installation programming will be starting on Saturday. Saturday, I will start the first program, setups and all that. Tomorrow topic about, yes, Java is independent platform. Tomorrow explaining about exe file dot class file. What is exactly exe file? Why exe file is dependent? Dot class, what is dot class file? How dot class independent platform? No doubt, tomorrow is a very interesting class. Okay. Yes, tomorrow explanation, that class you will not see anywhere. Even Google also will not give that kind of information. Very interesting class. Wonderful class, definitely. Tomorrow, I'll explain wonderful class. Don't miss it. See, you guys, you may be joining into my batch or not, that is secondary. But don't miss tomorrow's session. Okay. Yes, you may be joining into my batches or not, that is second. Leave it. But attend tomorrow. Tomorrow attend the class and see that wonderful explanation is very useful for you. Okay, see, you may be learning Java or not, that is secondary. You may be joining to my batch or not, that is secondary. So first of all, tomorrow try to understand class, a very useful class. Okay, yes, everywhere very useful information tomorrow. Tomorrow class, yes, about exe file, dot class file. Yes, those concepts we'll discuss. Okay. Yes, today class topic, it's there in document here. Yeah, this document I'm sharing with you. Yes, I think almost everyone paid for all students. Okay, except 1 or 2 guys, everyone paid for all students. This, yes, the drive access given, recordings and document, everything. Yes, still anyone pending access? Today I'll give it. By 10 o'clock, we'll get the access. All paid students will get the access by 10 o'clock, today by 10 o'clock. So this is today document here. Today class, interpreter compile differences. All the difference explained here. Next about Java. Java depends on both compile interpreter. That's explanation, very clearly explained here. Very clearly explained. Can we create EXE file in Java? No. So there is no concept of EXE file in Java. Okay, that's it. Yeah, that's it for today. So tomorrow about, yes, independent of platform, portability, these things we'll discuss. Yes, any doubts, guys? Any doubts? Yes, if no doubts, let us wind up session. Yes,
Thank you, sir.
yes, let us wind up session. Yes, 1 second, just a minute.
Thank you.
Thank you, sir.
Yeah, so already WhatsApp communication is going on. Yes, in WhatsApp, yes, that your group created already, communication is going on. Still anyone is not there in WhatsApp, share your information and add to group. Yeah, that's all. Thank you guys. See you tomorrow.